Hi students, this is Mrs. Bettis here with our first lesson of our new section on exponents and exponential functions. So lesson 1 is about 0 and negative exponents. 0, negative. So first thing, let's just remind ourselves about exponents. So here I have 3 to the 4th power, and the 3 is what we call the base, the 4 is our exponent, and the 4 tells us to multiply the 3 4 times. So here we have 1, 2, 3, 4 factors of 3. And that is what an exponent does. So we want to explore what happens with some of these exponential expressions here. So here I have 3 to the 4th power, and we've already said that that was 3 times 3 times 3 times 3. If I have 3 to the 3rd power, that is 3 times 3 times 3. 3 to the 2nd power would be 3 times 3. 3 to the 1st power would just be a 3 by itself. So let's just expand these just to know what these values are. 3 to the 4th power is 81. 3 to the 3rd power is 27. 3 to the 2nd power is 9. And 3 is just equal to 3. Well, what is the relationship between these values? Well, 81, if I divide 81 by 3, I end up with 27. If I divide 27 by 3, I end up with 9. And if I divide 9 by 3, I end up with 3. So it looks like we are dividing by 3 repeatedly as we travel down this table. Well, let's continue and see what happens. So the next step would stand to reason that if I want to get to this next value, I would have to again divide by 3. Well, what is 3 divided by 3? Well, that's 1. Well, let's see what that's equivalent to. Well, 3 to the 0 power has a value of 1 according to this pattern. Well, let's see if it works for the 2 also. So 2 to the 4th power is 2 times 2 times 2 times 2, and that is 16. 2 to the 3rd power is 2 times 2 times 2, that is 8. So it looks like we are dividing by 2 every time. 2 to the 2nd power is 2 times 2, that is 4. 2 to the 1st power is just 2, and that is a 2. So it looks like that pattern is extending even into our bases of 2. So here we divide it by 2. We divide it by 2 again, and we divide it by 2 again. If we wanted to keep going, we would just divide by 2 again, and that gives us a value of 1. So I got a 1 in this table as well. Is there a pattern there? Why, yes, there is. Our first exponent property is the 0 exponent property, and that rule says this: any non-zero number raised to the 0 power is going to equal 1. We saw that in our table of 3s and our table of 2s. Every time we got down to a 0 exponent, the value was 1, and that will always, always, always be the case. Let's look at some examples. Here I have an expression a times b raised to the 0 power. The 0 power is on the outside, so this has a value of 1. If I'm looking at example B, here I have a 3 times a heart squared with an x. All of that is being raised to 0 power, so it has a value of 1. Here, though, look at C. This is a little different. I have a 4 times x to the 0 power. Well, x to the 0 power, this part of the expression is 1. And then I have to multiply times 4. So that was going to be a 4, because this is essentially 4 times 1. And then lastly, let's look at D. I have a negative 5 times x to the 2nd power times y to the 0 power. Well, my y to the 0 power is a 1, and everything else remains the same, negative 5x squared. There you have it, 0 exponent property. Let's continue the exploration to see if we can understand a negative exponent. So in the first pattern, we were dividing by 3, dividing by 3, dividing by 3, and we stopped at a value of 1. Well, let's continue. What is 1 divided by 3? Well, that is 1/3. Hmm. Well, let's continue. What is 1/3 divided by 3? That's 1/9, or 1/3 squared. Let's keep going. 1/9 divided by 3. Well, that's 1/27. That's equivalent to 1/3 to the third. Let's look over at our 2 table. So if I divide 1 by a 2, then what I come up with is 1/2. If I continue this pattern, I end up with 1/4. And then lastly, I would end up with 1/8. These values are also very similar to me because I saw them at the top of the table. So 1/2, 1/4, that's the same as 1/2 to the second. 1/8 is 1/2 to the third. Looks like there's a pattern here as well. Can you figure it out? So for the negative exponent, we have ourselves another property. So while any non-zero number to the 0 power is equal to 1, what we discovered with the negative exponent is that it turned our expression into a fraction. All right. So a to the negative m power would be 1 over a to the positive m power. What you would notice is that before we had the same expression on the bottom as we did when we had the positive exponents from our table of 3 and 2. So this is the pattern. It creates for us a fraction. It also creates for us what's called a reciprocal. And that's where we flip our fraction over. Well, what happens if we have a negative exponent in the denominator? Well, that negative exponent is going to move my expression to the top and it's going to become positive. So this would simplify into a to the positive m power. So notice, after the negative does its work, it's now positive and it's no longer negative. So these are our 2 negative exponent properties, which create reciprocals. Let's look at some examples. 4 to the negative 2 power. Well, that is 1/4 to the second. So the job of the negative is to move my expression either to the bottom or to the top. And then we can simplify. 1/4 to the second is the same as 1/16. Let's look at example B. Here I have a 2 times x to the negative third power. Well, the 2 does not have a power on it, so the 2 will stay where it is. But the x to the negative third is a negative exponent, so I need to move this expression to the bottom. So the 2 will stay put, and the x to the third is now on the bottom. Notice it is not negative anymore, and notice the 2 stayed where it was. For example C, here I have a negative exponent on my A. I also have a negative exponent on the C in the denominator. So these expressions are going to move. The A will come down and the C will come up. Everything else will stay put. There is nothing making the other expressions change. So on the top, I now have B to the fourth, and I have C to the second. On the bottom, I have a 10 that was already there, and the A to the third now has moved to the bottom. In our last example, we have a 2 with no exponent, so it doesn't move. We have a b to the sixth, so it will not move. And in the denominator, we have a c to the negative fourth. It will move to the top. And it's going to join the other expressions already there. So our new answer is 2b to the sixth, c to the fourth. There is nothing left in the denominator, so we don't have to show it. But technically, this is what we have. This is the same as 2b to the sixth, c to the fourth. Okay, let's just make sure that we got it. Let's do a few more examples. 4 to the 0 power, that is a 1. Number 7, x to the 0 power, that is also a 1. Number 8, 5 to the 0 power times 3x. Well, 5 to the 0 is 1, and I'm just left with 3x. Let's look at number 9. There's lots of stuff going on in this problem, but let's just wipe away the things that we can. X to 0, that is a 1, so it's gone away. And now we have y to the third, x to the fourth, and y left over. Let's look at this next expression. Number 10, x to the 0 power goes away. So we are left with g to the third to the second. All right, let's go on. Number 11, y to the 0 is gone, 3 to the 0 is gone, and we are left with everything else. So hopefully you guys are catching the hang of it. Let's move to the negatives. So number 12, 6 to the negative 1 power is 1 over 6 to the positive 1 power. And you don't have to show that positive 1 power, so it's just 1 over 6. Notice it's not negative, it's just moved to the bottom. Number 13, this is now 1 over 8 to the second power, and that can be simplified into 1 over 64. Number 14, w to the negative 6 power is 1 over w to the 6th. Let's look at 15. So here I have t to the negative 2 and x squared. X squared is not negative, so it will stay. But t to the negative 2 is going to move to the bottom. So x squared is on top and t squared is on the bottom. That's it. Let's look at 16. Ooh, we have both. R to the 0 is a 1. We have a 2 with no power, so it will stay. A to the second is a positive exponent, so it will stay. But b to the negative 2, where is it going? To the bottom. So what we have on top is 2a to the second and b to the second on the bottom. Let's look at 17. E to the second, k to the negative 2. This has to move to the bottom. So what we have is e to the second. The k to the negative 2 is now on the bottom as a positive, and that expression is being raised to the third power. Here we have a negative exponent on the bottom. So where does it go? It is going to the top. So we have 3 to the positive third power times x. That can be simplified into 27x. Next expression, we have a u to the 0. Oh, that's gone away. And then we have a y to the negative fifth. Where does it go? To the top. So we have x to the fourth, y to the second, y to the fifth on top, and x to the second on bottom. That's it. And the last one, all this big old stuff doesn't matter. There's a 0 exponent on the outside. So what's the answer? 1. You got it. Good job.